In this next section, we're going to take a look at special cases of factoring, or special cases of the distributive property or multiplication. So we've already seen a problem, we've already seen one of these in the word problem in the last section, when you had to multiply x plus 1 times x plus 1. What this setup is going to produce is what we call a perfect square trinomial. So that means that the first term in the trinomial is going to be a perfect square, and the last term in the trinomial is going to be a perfect square, and there's going to be a couple of other conditions. We'll get to that later when we actually start doing the factoring portion of it. But what you want to know here is that if you've got x plus 8 squared, you've got to take yourself back to what is the definition of a square. The definition of a square is you're going to take a number and multiply it by itself. So what is being squared here is x plus 8. So you can rewrite this as x plus 8 times x plus 8. And then what we'll do is just FOIL this. X times x is x squared. X times 8 is 8x. 8 times x is 8x. And then 8 times 8 is 64. So at this point, combine like terms, and you get x squared plus 16x plus 64. You can see that this x squared is a perfect square. If we take the square root of x squared, we get x. If we take the square root of 64, we get 8. So that's going to be something that you want to keep in mind for as we move into later sections. Now in the second one, we've got 2m minus 3 squared. Don't allow this to fluster you at all. Just follow your rules. You know that if you've got something being squared, you know that it's times itself. So 2m minus 3 times 2m minus 3. And so we're going to apply FOIL. 2m times 2m is 4m squared. 2m times negative 3 is negative 6m. Negative 3 times 2m is negative 6m. And then negative 3 times negative 3 is positive 9. So then we're going to get 4m squared minus 12m plus 9. And you can see 4 is a perfect square, m squared is a perfect square, and 9 is a perfect square. And that's how you work out the perfect square trinomial. Again, for problem number 2, we're going to be looking at a word problem. In this case, we're given that we've got an outdoor patio is surrounded by a walkway. The walkway is 3 feet all the way around, and both the patio and the walkway that go around it are squares. And so what we want to do is we want to figure out what is the area of the walkway. So again, you want to conceptualize this and think about what exactly are you doing. You're going to be finding the area of this walkway. So the area of the walkway is going to be equal to the area of the large square minus the area of the small square. So now you need to ask yourself, what are the formulas for the area of a square? So we're going to go A sub W is equal to S squared minus S squared. Now, what is the given information that we've got for the large square? The large square is x plus 6. So we're going to plug in x plus 6 for that first S, minus we have that the length of the patio, or the length of the side of the patio is x. So we're going to put in x, and then that gets squared. Now all we've got to do is simplify and solve. So x plus 6 times x plus 6. I'm just going to rewrite this so that you can see it'll be a little bit easier to do this. X times x is x squared. X times 6 is 6x. 6 times x is 6x. And then 6 times 6 is 36. Don't forget to bring down the minus x squared. So now we combine any like terms. Well, this x squared and this x squared, they cancel out. Then you got 6x plus 6x is equal to 12x plus 36. Now, what you can do is you can take out the 12, because that's the greatest common factor, and you're left with x plus 3. So your solution is going to be x plus 3, or 12x plus 36 square feet. Problem number 4 is our second special case for multiplication. And what it's going to do is it's going to lead us to something we call difference of squares. And the reason why it's called difference of squares is because your solution is going to be both terms are going to be perfect squares, and they're going to be subtracting from each other. We'll see that when we get to the solution. In order to get to the solution, there's a special rule that you can know about this. You can actually eliminate the O and the I from FOIL when you do this. The reason why is because those two terms, the outside, the result of the outside and the result of the inside multiplication, are going to end up canceling each other out. So I'm going to show you the long way first, and then I'll show you the shortcut. So if we do FOIL on x cubed plus 8 times x cubed minus 8, you're going to get x to the 6th, and then minus 8x cubed plus 8x cubed, and then minus 64. So these two are going to cancel, and you're left with x to the 6th minus 64. Or you can do the quick way, which is going to be, if you've got x cubed plus 8 times x cubed minus 8, let's just worry about the first and the last terms. So x cubed times x cubed is x to the 6th, and positive 8 times negative 8 is negative 64. So you can see that you get to the same answer, but it's going to save you a little bit of time. Now, the reason again why it's called difference of squares, let's take a look at the results. If you take the square root of x to the 6th, you are going to get x cubed. So we get a perfect square. There's nothing left inside the radical. Then if you take the square root of 64, you're going to get 8. So both of those terms are perfect squares. And then what is separating them? A subtraction sign. So that's again why we call it difference of squares.